Which of the following equations is equivalent to 4 to the power of x plus 2 equals 16? All right. So 4 to the power of x plus 2 equals 16. Step 1. Take the log base 4 of both sides. So log base 4 of 4 to the x plus 2 equals log base 4 of 16. Simplify to get x plus 2 equals log base 4 of 16. Now the reason this works is because the log base 4 cancels out the base. Log base 4 of 4 to the power of something just equals the exponent. So that's why that works. X plus 2 equals log base 4 of 16. And then if we go back to our x plus 2 equals log base 4 of 16. X plus 2 equals log base 4 of 16. They just have it written backwards, but it's the same thing. Log base 4 of 16 equals x plus 2. D is the answer. Numerical response: when the expression log base 8 of 6 plus log base 8 of 4 is simplified into the form log base 8 of a, the value of a is. Okay, well. So at first glance, this might look a little bit intimidating, but since we know how to handle it, it's no problem. We know that anytime two logs of the same base are added together, you get to multiply their contents. So log base 8 of 6 plus log base 8 of 4 equals log base 8 of, what's 6 times 4? 24. Log base 8 of 24. So the value of a is just 24. An expression that is equivalent to 3 log a minus 3 log b is. Right. 3 log a minus 3 log b. Factor it to get, so I'm just factoring out the 3, to get log a minus log b. Since we have a difference of 2 logs with the same base, divide the contents of the first log by the contents of the second log we have. So it's 2 logs of the same base. We take the contents and divide them because we have the first log subtracted by the second log. We can combine them to say log a minus log b is equal to log a divided by b. So that's all I did. I took this, changed it to this. The number in front of the log becomes the exponent of the contents. It's the other thing we're allowed to do when we're dealing with logs, is take the coefficient in front, the 3, and bring it up here. So 3 log a over b becomes log a over b cubed. Actually, I didn't really write that properly. This should have square. No, what I mean to say is that it's, yeah, this is definitely written wrong. There should be a square bracket here and a square bracket out here, because this does not mean log a over b, the whole thing cubed. It's the log of a over b cubed. So this was unclear and written incorrectly. However, when we look at the choices here, the answer is D, even though D is written incorrectly. There should be square brackets here and a square bracket out here. Square bracket, square bracket. But the answer is D. What they're trying to say is that the cube belongs to the contents here, not the entire log. So that's the confusion. But the answer definitely here is D. Yes, okay. So which of the following equations could be used to algebraically solve the exponential equation? 3 to the power of x minus 1 equals 9 to the power of x minus 3. Okay, so what we're given is 3 to the power of x minus 1 equals 9 to the power of x minus 3. So what do we do with this? Well, we notice that 9 is equal to 3 squared, and we want to make these two look as similar as possible, so we just substitute 3 squared where 9 used to be. So now this equals 3 squared times this, and now what we're allowed to do is, because we have a power to a power, we're allowed to multiply the exponents. So I took the 2 in here, multiplied it by the exponent out here, and then finally expand the bracket to get 3 to the power of 2x minus 6. So 3 to the 3x minus 1 equals 3 to the 2x minus 6. Back to our problem. 3 to the 3x minus 1 equals 3 to the 2x minus 6. There's our answer, B. From 1997 to 2008, the population of a particular town grew at an average rate of 5.4% per annum. During this 11-year period, its population P can be modeled by the exponential function. P equals x times 1 plus r to the n, where x is the population in 1997, r is the average annual growth rate, n is the number of years since 1997. In 2008, the population was 14,030. According to the model, the population of this town in 1997 is approximately. Okay, so how are we going to handle this one? We start out with our equation P equals x times 1 plus r to the n. Step 1, insert the data given to solve for x. Okay, so what data are we given? We're given the population in 2008, which is 14,030. We're given the average growth rate of 5.4% per year, which is 0.054. The slash A just means per annum, which means per year. So 0.054. And it's an 11-year period. 1997 to 2008, 11 years, obviously. Okay, so let's use that information in a way that will help us. In 2008, I'm just going to put P underscore 2008 equals 14,030, the population in 2008. N equals 11 since 2008 is 11 years after 1997. And we know that the growth rate is always R equals 0.054. Thus, we just plug our data in. The P in 2008 is 14,030. X we don't know yet. 1 plus R to the power of 11 years. N is equal to 11. Okay, let's just add the bracket. 1 plus 0.054 is 1.054. Now, we have to solve for x. In order to do that, we just divide both sides by 1.054 to the 11. That comes underneath here. X equals 14,030 divided by 1.054 to the 11. And once you calculate that out in your calculator, you will get 7,867. And that's the value of x. So now we find the population in 1997 using n equals 0 because n is defined as the number of years after 1997. So if we want to know the population at 1997, n is equal to 0, we have p at 1997 equals 7867 times 1 plus 0.054 to the power of 0. And any number to the power of 0 is just 1 automatically, except for 0 to the power of 0. But that's a different conversation for a different day. For right now, this to the power of 0 is just 1, and our final answer is just 7,867. Okay. And there we go. Our answer is D. 7,867. The 2010 earthquake in Haiti measured 7.0 on the Richter scale. In 2004, the earthquake off Indonesia measured 9.1 on the same scale, caused a tsunami. In order to compare the relative intensities I of the two earthquakes, the following formula may be used, where M and N are the Richter scale values of each earthquake. Sure. Compared to the earthquake in Haiti, the earthquake off Indonesia to the nearest whole number was how many times stronger? Okay, so what they're asking for is the value of I. When M, the larger earthquake, is 9.1, so we put the 9.1 up here, and the less intense earthquake is the 7.0, so we put 7.0 in here. Step 1, plug the Richter scale values into the formula. Okay, so like I said, the M here is going to be 9.1, the N here is going to be 7.0. Cool. Step 2, since we are dividing two powers of the same base, we can subtract the exponents. So you have two powers that are divided by each other, they have the same base, you can subtract the exponents. So this becomes 10 to the power of 9.1 minus 7.0. Simplify to get, just subtract them. 10 to the 2.1 equals 125.9. So believe it or not, the stronger earthquake was 125.9 times more intense than the softer earthquake. And the softer earthquake was the one in Haiti, so you can only imagine how powerful the Indonesia one was. It's amazing. Ahmed invested $1,000 for 4 years into an account that pays 3% per annum, compounded annually. Which of the following functions models the value V of Ahmed's investment in 4 years' time? Oh, we're not into that problem yet. Okay, so Ahmed invested $1,000. So the principal, $1,000 is the initial amount that he invested. So that's the principal, which is 1,000. The rate of interest is 3%. So we're obviously going to have 1.03, which is 1 plus the rate of return. So the answer is not B and it's not D. And it compounds, it's compounding interest that compounds over 4 years, so it's exponent. It's not simple interest, it's compounding interest, which means that we're using exponents. So the answer is A, 1,000 times 1.03 to the power of 4.